Hello everyone, here is a brilliant problem and now I'll be solving it using the concept of maxima and minima. Earlier I solved the same problem using the concept of the relative motion. Basically what we will do, we'll plot a picture. We will find the distance between the ship A and B at time t, and using the differential calculus, using the concept of maxima and minima, we will find the moment of time at which the distance between them will be shortest. Got the idea? Let's begin. Suppose in this direction we consider the north. Here we consider the south. This is west and here is the east. According to the problem statement, the ship A is moving along west with a speed of 10 km per hour. This is the position of ship A at t is equal to 0. Agree? Ship B is 100 km south. So from ship A I am going 100 km south. Let's say this distance I consider as 100 km. Here is the ship B. That ship B is also moving with a speed of 10 km per hour. It's given in the question. Agree. Initial distance at t is equal to 0 between them is 100. After some time, let's say the ship B reaches here. This is the location of ship B at time t. This t we are taking in r. So the ship B has traveled this much distance. Speed into time. Speed is 10 km per hour. Time we are taking in r. So speed into time is the distance traveled by the ship B. In that much t time interval, the ship A will also travel the distance 10t. Speed into time. And this is the position of ship A at time t. Agree? Now, what is the distance between ship A and B? Correct. This is the distance between ship A and B. I am calling this distance as, let's say, capital D. Using the Pythagoras theorem in this triangle, we can easily obtain the capital D. This length of the triangle is 10t. And how much is this length? Speak up. Correct. This is 100 minus 10t. So, first of all, I am writing that distance capital D. It will be root of 10t square plus 100 minus 10t square. Agree? We want to minimize the distance between ship A and B. And the concept of maxima minima says whenever a quantity is maximum or minimum, its first differentiation is 0. So for minimum value of D, what we should write? D by dt of capital D should be equal to 0. You agree? For minimum value of capital D, the first differentiation should be 0. So doing the differentiation, d by dt, first of all will differentiate this root, means this power half. I am writing this again, 10t whole square plus 100 minus 10t square power half. You might remember the chain rule or the outside inside rule. First we'll differentiate this power and then we'll differentiate the inside content of this bigger bracket. So I'm differentiating the data here, pay attention. 100t square plus 100 minus 10t whole square power half, and we have to make it equal to 0. Differentiating the power first. So half this entire bracket 100t square plus 100 minus 10t whole square. Power will become half minus 1. N something to power n minus 1 into, now we will differentiate the inside contents. 100 is some constant. So it is taken outside of the differentiation, and then differentiation of t square will be 2t. Differentiating this power again. So 2 comes here, and then this entire bracket 100 minus 10t power 2 minus 1. Then differentiating the inside data, which is 0 because 100 is a constant. And then differentiation of t will become 1, and this minus 10 will be taken outside of the differentiation. And this entire computation should be equal to 0. You agree with this? Let us simplify this. We can write this as 1 by 2 root 100t square plus 100 minus 10t whole square into, simplifying the things further here, this is 200t. Multiplying this minus 10 and this 2, so it will be minus 2000. 2 into 100 is 200, and then minus 10 is multiplied, plus this is 20, and this 10 is also getting multiplied, so 200t, and 2 minus 1, that power was actually 1. This entire computation is equal to 0. This data has been sent to RHS. Okay, now we are left with this. This entire term should be equal to 0. This entire term has been shifted to RHS. Simplifying this, 200t plus 200t. So basically we have 400t is equal to 2000. So what we are getting, the t comes out to be 5r. Got the answer? I hope you like this way of solving the question, and if you don't like it, you can use the relative motion. Check the other video. Stay awesome. See you.